This question requires a bit of care because basically we're being asked to find the prime factorization of 290,224. And then we're going to worry about the two-digit factors. So I'm going to write this number down, and you need to be aware of some, you need to find the factors, but being aware of some divisibility tricks can or rules can really help. We can see it's even, but instead of dividing by 2, can we divide by something bigger? Well, I saw the 24 and I thought, okay, maybe 8 goes into it. And actually, the rule for 8 is that you look at the last three digits, and if they are divisible by 8, then the number will be divisible by 8. Because 8 goes into 1,000, so the 290,000 will necessarily be divisible by 8. So 224, well, 160 is clearly divisible by 8, and if I add 64 on, I would get 224. So this is going to work, and I'm going to go straight for that. It might be that 16 goes into it, but I just thought, first of all, that's harder to divide by, and yeah, let's just make the numbers smaller. So 8s into 29 go 3, goes 24, remainder 5. 8s into 50 are going to go 6, remainder 2, then 2, remainder 6, then 7, remainder 6, and there we are. We've got 36,278. Okay, and I'm going to sort of just keep up here a little record of what I've got. So it's going to be 8 times something. Right, now divisibility rule for 4, if the last two digits are divisible by 4, this clearly isn't. So, but it is divisible by 2, so I'm going to break it down a bit more. So 2's into 36,278. We go 1, 8, 1, 3, 9. Okay, so I've got 8 times 2. Okay, 36,278 now we've got to worry about. No, sorry, that with that. 18139. Right, it's always worth looking for divisibility by 3. So the digits add up to 10, 22. So actually 3 is not going to go into that. So I actually can't remember the trick for 7. I think for 7 it's quicker to just do the division, see if it works. So 2's, but all the numbers are going to be bigger than powers of 2 or 3 now. So 7's into 18, go twice. And here we get 5. Then, okay, so 7's not going to work, in fact. Then it's all about we don't need to check 8 or 9 or 10, so 11 next. You can normally spot it for smaller numbers when 11's a factor because you get like palindromic numbers, but maybe it will work here because I think the pattern breaks. So 11's into 18, go 1, remainder 7, then 6. 11's quite easy to divide by actually. So here we're going to get 44, and yes, we're going to be left with 99, so 9. Okay, so 8 times 2 times 11. We got 1649. So you might, again, we know that 2, 3, 5 isn't going to work, 7, 11. But maybe 11 goes into it a second time. It's worth just checking. So 11's, I get 1. Here I'm good. No, that's not going to work because I'll get 4 here, then I get 109. And it was 110 that would work. Okay, let's try 13. So 1, I get 26, so 8, and 13 doesn't go into 89. I don't need to try 14, 15, so 17. Okay, it's quite time consuming, but I don't really think there's a quicker way than this. 17's, okay, I'm going to get 9 here. So that would be 153. Like if it helps, you can write down some of your times tables, and you can even use long division and sort of subtract it more formally. So that will give me 11, bring the 9 down, so 119. Or you could just stick the 11 up here. Okay, does 17 go into 119? If it does, then it's got to surely end in a 7 to get the 9. So I'll get 70 plus 49, which is 119. So it's going to be 7 times. So I've got 17. Now actually 97 is a prime number. Okay, we've got our prime factorization nearly. let me just write, so 290,224 is going to equal 2 to the power of 4 times 11 times 17 times 97. Okay, now we've got to still do a little bit of work. We've got to get these two-digit factors. So straight away, I'm going to get 97, I'm going to get 17, and I'm going to get 11. And I'm also going to get 16 when I do 2 to the power of 4. So, okay, I've dealt with that. And I'll add them up in a bit, actually. So now I'm going to think about what happens if I use 2 with one of these. I'm going to get 22, and I'm going to get 34. That's not going to help with 2 times 97. That's going to be 3 digits. Okay, I'll add them up separately. Right, now 4. 4 times 11 is going to give me 44. 4 times 17 is going to give me 68. Okay, next up, 8. I'm going to get 88. And 8 times 17 is going to be too big. And then it's just 16, which isn't going to work with any of them. So that's going to be it. Right, so let's add these up. 14, 15, 21, 30, 50, 141. Here I've got 56. Here I've got 112 and 88 just by itself. Okay, let's put it all together now. 141, 112. Might just do 56 plus 88 over here. 144. Okay, adding these up, I'm going to get 7, 9, 3. Oh, after all that, there's our answer, 397.